Okay, so this is a video series on the 555 timer. It is a IC chip that is going to help us keep time in two ways. So I'm going to teach you two ways where this fella is going to help us keep time, okay, depending on how we pin it up and configure it. So why do we want to keep time? Now, very simple. When we go to a traffic light, yeah, when we go to a traffic light, we want the green light, for example. We want a green light at the traffic light to turn on for a certain period of time, right? We don't want it too long. We don't want it too short. We want a green light. Let's say I have a green light and it's going to turn on for a fixed period of time. Cars can go, cars can go, cars can go, and then it's going to turn off. Yeah, and then cars have to stop. So I want it to help me keep a certain amount of time. So this is one way which the 555 timer can help me in my daily life. Another way is, let's say we are talking about the traffic light, and now I'm talking about the green man. Okay, now, after a while, the green man will start to flash. Yeah, if you can just picture it in your head, after a while, the green man will start to flash, and so the green man turns on, off, on, off, on, off, on, off. Okay, so this is the green man flashing on, off, on, off, on, off. So basically, the 555 timer is able to help me keep this type of time and this type of time. You'll know in your later on in a few minutes time that this will be called a monostable multivibrator mode, and this is a astable multivibrator mode. Okay, so let's get into the lesson proper. All right, so this is what a 555 timer looks like. It's very similar to the LM311 in it that it is a DIL package with 8 legs, but the legs of course will stand for different things. Yeah, similar to the LM311, pin 1, 2, 3, 4, 5, 6, 7, 8. Pin 1 is your ground, pin 8 is your VCC, and we are going to find out what each of these things do. Okay, ground, of course, connected to ground. And I'm not going to go through what these means because depending on whether I want to configure it as an astable or a monostable, the pins will be connected differently. Okay, so let's look at, so this is the symbol for a 555 timer. Okay, when you draw it in your multisim or when you draw it in your circuit diagram, this is how it should look like. And I'm going to show you how to pin it up as a monostable vibrator. So this is a monostable where it goes up for a while and then it goes down one time. That's it, done, full stop, finish. Okay, so this is how I'm going to pin it up. All right. VCC, of course, goes to VCC. Reset goes to VCC. Yeah. I'm going to short my threshold and my discharge. So short pin 6 and 7 together. And this will be put in between a RC circuit. Okay. Pin 2 will be the trigger. For the trigger, I need some sort of a button. And in this case, when the button is open, I need it to be a high. Okay, I first need it to be a high. Okay, remember this. This is very important. I need it to be a high first. Okay. Uh, Pin 1 is your ground, so connect it to ground. Pin 5 is your control. Put a 10 nano farad from ground control to ground, and pin 3 is your output. So this will go to wherever you want it to go high for a set period of time. Can be an LED, can be a buzzer, whatever it is. Okay, so what happens is that when you press this switch, press it down, this fella will go low. Now it's very easy to say that this value is going to be triggered by a falling edge. Yes, but how it works is that the moment this signal trigger goes below 1/3 VCC. So once it drops below 1/3 of the VCC, it's going to go up. Yeah, it's going to go up. So the output will start manifesting its high output. Okay, so it will only go down low. It will go down low when pin 6 over here notices that is going to go above 2/3 VCC. So here is when the trigger goes below 1/3 VCC, and here is when pin 6 notices that it's going above 2/3 VCC. So it drops the output down. Now you'll be wondering, whoa, how does it work? Why does it do that? I don't know. No, honestly, I don't know. I don't know how 555 timer internal circuitry is, and to be honest, I don't care. I'll take this as a magic black box, so long as I wire it up this way, and I click the trigger, I will be able to get a monostable signal out. So again, really, I don't care how it does it. I don't care how it notices that it's below 1/3, it is above 2/3 VCC. I don't care. And actually, neither should you. Okay, unless you are going into like chip design next time. Well, if you do, come back and share with me. Okay. So what I've just described is written here. You can go read it in your textbook. And this is the timing diagram. So this is your trigger at pin 2, right? This is your trigger. Okay, so trigger, once you hit the trigger, it falls below 1/3 VCC. Your output is going to go high. And at pin 6, this is at pin 6, the moment it goes to 2/3 VCC, the output is going to go low. Okay, so just remember this. Don't be too intimidated about, oh, why does it work that way? How does it do that? Doesn't matter. It's a magic black box. Okay. Another thing that you have to know about a 555 timer configured as a monostable multivibrator is this. So T is your pulse width, how long it stays high for. Okay, this is your pulse width. So I can actually calculate the pulse width based on my resistor and my capacitor value. Okay, so if you remember, I've got a resistor R1 and a capacitor C1. If I take these two values, multiply them together with 1.1, I'll be able to calculate out my pulse width. Okay, so if I want a longer pulse width, I can either increase my resistor or I can increase my capacitor value, up to you. Yeah, so you can go and read work examples 14.3 yourself, 14.4, and go and try how to do review question 14.2. Yeah, try and draw it out yourself. Okay, go and remember it. Go and try and draw it out. Remember the connections. Yeah, uh, and yeah, so this is basically the 555 timer as a monostable. Go and remember how the connections work. Go and remember what happens when I trigger pin 2 down to below 1/3 VCC. Go and remember how to calculate the pulse width T equals to 1.1 RC, and you should be good. So just go and practice more on your calculations and your drawing, and that's about it. The main thing about this chapter is that we are going to use it a lot in our practical. Yeah, so it's very important to know the theory, but it's also more and equally important to know about how we use it on the breadboard for our prototyping. Okay, so the next video I'll show you how it is configured as a stable multivibrator.